today's topic is a continuation of where we were speaking on from last time. So we finished the bony architecture, the cells, the matrix surrounding it, uh, what are the different types of remodeling, what are the different types of bone formation, that's endochondral, intramembranous, and appositional bone formation. So today, what we are going to learn about is an extension of the enchondral bone ossification, because one of the examples of enchondral bone ossification was the physial growth. Okay, so now whenever you're talking about physial growth, it is always bone which forms on top of a cartilage precursor, and that's why it is a continuation of the enchondral bone formation. Now, the epiphyseal plate is an important part, so which we also call the physis. The physis and the epiphyseal plate are the same, and it's important for the longitudinal growth of the bone. That means whenever a bone grows in length, it is a long bone grows in length. It's primarily because of the physeal growth. Okay, so there are two types of physes. Okay, so the first type of physis is what all of us know, and we call that the horizontal physis. Now, if you see the area marked under the red banner there, so that is the area of the horizontal physis, and that is a more, what do you call it? It's a more organized sort of a physis where growth takes place longitudinally. Whereas the second type of physis, is known as the spherical physis. Now, the spherical physis is a less organized sort of a physis, and this is involved for the growth of the epiphysis, alone. Okay. Now, this is less organized, and that is why we are not going to be talking much about the spherical the spherical physis. So, to delineate, that is the region of the spherical physis. And the bone, generally, if you see, say, if you take a bony end, say of the distal femur or the proximal tibia, whatever you see above the physis, that is the epiphysis, grows with the help of a spherical physeal growth. Okay, it is less organized. There is very less we know about it compared to the horizontal physis. Now, coming to the horizontal physis, we know that normal physis consists of 4 zones of cartilage. We have the resting zone or the reserve zone or the germinal zone. We have the proliferative zone. We have the hypertrophic zone, as well as the zone of provisional calcification. Okay, so these are the 4 zones. In some textbooks and even in the Western literature, it's only 3 zones, and the 4th zone, that is the zone of provisional calcification, is a part of the hypertrophic zone. Okay, so under hypertrophic zone itself, there are 3 parts. We have the zone of maturation. We have zone of degeneration. And then lastly, the zone of provisional calcification. So you can either write it as 3 zones or 4 zones. But remember, for the ease of understanding and how we have been traditionally taught in the Indian subcontinent, we are generally having 4 zones of cartilage: the resting zone, the proliferative zone, the hypertrophic zone, and the zone of provisional calcification. So let's talk about this in detail. Okay. So if we take a cross section, so that's the same cross section of the horizontal physis. The first zone, which is closest to the epiphysis. So if I show it to you in the diagram here, this is when we see an X-ray, we see the bone till here, and then we can see an epiphysis over here. The rest of the region, that is this region, is generally radiolucent. We are not able to see this on the X-ray because it is majority of this region is physis, and physis is always cartilaginous. Okay, so that is why they are radiolucent. So the zone which is closest to the epiphysis is the germinal zone. Okay, so this is the epiphysis here. This is the diaphysis. Okay, So the zone closest to the epiphysis is known as the germinal zone or the resting zone. Now, what is, if you see the middle part, if you see this region here, we can see that there is blood supply. But if you see very clearly, the blood supply which is coming in through the epimetaphyseal arteries is not supplying anything in that zone. It is just passing through that entire zone and does not supply anything. Remember, the chondrocytes have their nutrition through diffusion. It does not get its nutrition through blood supply. So as soon as blood supply is given to a cartilaginous matrix, it starts to ossify. Okay, it starts to ossify because there is an influx of osteoclasts followed by osteoblastic activity. Okay, so that is why, remember, in the reserve zone, there is no blood supply which is directly supplying it, but there are vessels which will traverse this region without supplying it. So what is the function of the germinal zone? So the germinal zone basically has chondrocytes which are in the resting phase. So those bilobe nuclei are going to be present. They're going to be having a lot of lipids, glycogen, carbohydrates. There is going to be decreased oxygen tension, of course, because there is no direct blood supply to this region. And if at all, okay, so the main function of the zone is to store the metabolic substrates which are required for the cartilage growth. Okay, now if storage is deficient, this region will be affected. So the storage diseases which we know are which will cause problems are lysosomal storage diseases, and germinal zone or resting zone is going to be the diseases which affect the germinal zone or the resting zone are going to be the lysosomal storage disorders. Okay, so diseases affecting germinal zone are lysosomal storage disorders. We can have diastrophic dysplasia, which happens at this region, or diastrophic dwarfism. We can have pseudoachondroplasia. And we can have niche syndrome. So these are 4 conditions which can affect the resting zone as well. But remember, these 3 can affect all the other zones as well. Okay, so defects will be there in other zones as well, whereas lysosomal storage disorders are going to be particularly affecting the germinal zone or the resting zone itself. Okay, now one more additional thing that the germinal zone will be having is in this region on the top, because it functions as an anchor of the physis to the epiphysis. So functions as an anchor of the epiphysis to the physis. Okay. So then if we go lower down, progressing towards the diaphysis, we will enter the proliferative zone. Over here, if you see, one of the cells of the chondrocyte starts to align itself and starts to replicate. So this is the zone of replication or the zone of proliferation. So they increase in number, and this process is known as stacking of chondrocytes. So they stack one on top of the other, but they remain the same in size. Okay. So cell proliferation takes place, matrix production takes place here. Now, since there is blood supply, if you see the blood supply which has passed through so this was the resting zone here. So you see the blood supply which has not supplied